All right, guys, this is the second example for today. This is with diffusion rates and times and whatnot. And so the equation that we had was, what was it? The equation we had for the diffusion gases is the rate of 1 versus 2. So equals T2 over T1. So what this is saying is the rate of 1, like the rate of diffusion, is inversely proportional to the time. So in other words, the faster the rate, the smaller the time, right? So as one goes up, the other goes down. So that's why like this ratio, like they are inverse. So that's how we get R1 over R2 equals T2 over T1. So again, the rate of gas 1 is inversely proportional to the time that it takes to diffuse. The rate of diffusion for gas 2 is inversely proportional to the time it takes for gas 2 to diffuse, right? So as the rate goes up, the time goes down. Rate goes up, time goes down. Like they go opposite of each other. Now, this is also equal to the square root of the molar mass of gas 2 over the molar mass of gas 1. Why? Because nature. So for us, what are we given here? Like the variables we have are pretty simple. We have the time for the hydrocarbon. The time for our hydrocarbon is listed as 1.50 minutes. And the time for the bromine, I'm gonna do this again, guys. Look, remember, N over down, and don't forget the H. The time for the bromine, they gave us is 4.73. And I'm going to show you right now, see how it's time over time? That means that these units are going to cancel out, and this is going to be a unitless calculation, which is actually going to be like pretty nice. And because we're given minutes, this is not the rate of diffusion. This is the time of diffusion, right? So we're not going to use this. We're going to use this right here. You picking up what I'm putting down there? Kind of hope so, because here we go. Right, so I don't know. I'm just going to put hydrocarbon on top. So the time for the hydrocarbon is 1.50. And the time for the bromine is 4.73. Units cancel out. And remember, I'm calling the hydrocarbon gas 2 and bromine gas 1, whatever. It doesn't really matter as long as they both kind of line up, right? So this will be equal to the molar mass of my hydrocarbon divided by the molar mass of bromine, which I should know. Like you can just look it up. BR, like find the mass of bromine on your periodic table, multiply it by 2, you get 159.8. Ish, maybe it rounds differently, I don't really know. And again, this is molar mass divided by molar mass. The units are just going to cancel out, so we're basically going to be left with like a unitless calculation. Does that make sense? Like unitless, so everything cancels out and everything's really wonderful. So the way that I'm going to solve this is this square root. I don't like that, so I'm going to square both sides. You dig? Now all I got to do is multiply both sides by 159.8 to get my molar mass all by itself. So it'll be 159.8 times 1.50 divided by 4.73 squared. That will give me the molar mass of my hydrocarbon. So slap all that info into your handy-dandy calculator, do your calculations and mathing and whatnot, and what we're going to get is that the molar mass of your hydrocarbon will be about, what did I get, 15.990? Which, as far as I'm concerned, is pretty close to 16 grams per mole. So what could the chemical formula possibly be? Well, if carbon equals 12 grams per mole, That leaves us with 4 additional grams per mole. And if you remember, every carbon likes how many bonds? 4. And there's only one element that could possibly give us 4 more grams per mole. Would be hydrogen. It's about 16, right? There you go. Not that bad, right? Have fun.